So here's a series of really quick videos to take you through some of the key concepts you're going to need. So the first one actually isn't related to forces specifically, but a little bit more generically some of the units that you're going to come across that you will need to understand. So firstly, some of the useful units you're going to come across, not exhaustive, but it does do most of them. And this is distance, displacements, lengths, heights. All of those things, of course, are going to be in meters. Speeds and velocities, meters per second. Acceleration is meters per second squared. Forces are newtons. Put that there as well. Inertia, you're not really going to have to worry about the unit of this because you're probably not going to write any numbers down, but it also has a unit of kilograms, much like mass. Energy is in joules. Momentum, kilogram meters per second, not kilograms per meter per second. Moments and torque is about force times distance, so like lever action. So this is force times distance, which would be Newton meters, not again newtons per meter. Temperature, you might be aware of degrees C, but actually the proper unit for this is the Kelvin, which would be K. Now you're probably okay to get away with using degrees C, but if you're using it in equations, you just need to be careful that you've got it in the right form. You don't need to worry too much about this, but there are some base units. These are units that make up everything. So everything like forces, momentum, are all made up out of these units. These are the fundamental ones. Again, you don't need to know them or worry about them too much. Just be aware that there are 4 units of mass, kilograms, seconds, and Kelvin that make up everything else. So you don't have to know it so much. You just have to bear it in mind. It's a useful idea that might come up again. There are 3 at the bottom of this list that you're probably not really ever going to make use of. Okay, compound units. So this is where we've got units that are made up of 2 different units. So we've covered some of these already. So what I just want to do is cover alternative notation that you will come across. Okay, so the proper notation for writing meters per second is to use a little power of -1. Now, I don't want to really go into the maths of this too much, but in maths, a way of writing that something is underneath a fraction is to give it a negative power. It's just alternative notation, and you might find that, well, that's really annoying, but unfortunately it is quite standard notation. It'll probably be quite new to you, so it's something you'll have to get used to seeing. At this stage, it doesn't matter which way you write your notation, but you will see both, so be prepared to understand what it means. So what's really going on here is meters per second is like meters divided by seconds. Just like we did with the x there, the s can become -1. So those two are the same thing. Now, it's a little bit clearer. It doesn't make a massive amount of difference a lot of the time. But when things are typed or when units get complicated, it's a lot clearer to use this notation. And besides which, it doesn't really matter whether you like it or not. It does exist. So you've got to get used to seeing it. That's the important idea. Okay, so just to do some others where you'll need to know similar notation, we've said acceleration is meters per second squared. So that could be written like this. Gravitational field strength, so this is newtons per kilogram. So again, could be written like that. Acceleration due to gravity, well, again, it's acceleration, so same 2 versions. It's worth noting that these 2 are identical. I know they don't look it, but they do mean exactly the same thing. Acceleration due to gravity, gravitational field strength is 9.81, whichever unit you see it in. So it's also just worth noting that you'll see G written both ways. It means the same thing, okay? So don't worry too much if you see a different version of the unit. Momentum is mass times velocity, so that gives us kilograms meters per second, which could be written like that. Moments, torques, levers, this again is a force times distance. So this is Newton meters, not newtons per meter. Nope. Don't write it like that this time. There is no / there, even though we sort of want to say it with one. It's just Newton meters. On to derived forces. There's only really a couple that you need to know about. There are some more like hertz for frequency, but the main ones are going to be force, which is the Newton, as we've said, and energy, which is joules. So the Newton is made up of, if you think of the equation for force, F equals ma, mass times acceleration, so kilograms meters per second squared. Joules, if we pick any of the equations for energy, so kinetic energy, half mv squared, the half doesn't matter. Kilograms, m, so v squared would be meters per second, but it's squared, so both bits get squared. Again, I'm not expecting you to remember or understand that, but it's just something to be aware of, that these units are made up of some of these base standard units. They're not units in their own right, they consist of other things. So make sure, the only thing you have to make sure is that you know the units for the main quantities. So this initial list up here, you have to know the right units for the right quantities. Otherwise, it can be very confusing. If you're writing about a force, but you put joules, what you're writing suddenly stops making sense, and that can cause problems in technical writing.